Hi, this is Mr. Manley. In this video, I am going to look at solving a word problem, which is a quadratic application. So let's read this word problem about 240 meters of fence and forming three sides of a rectangular field. So that's down here, 1, 2, 3. And that's all we need as far as the fencing goes, because this fourth side is a river. So it won't need a fence. So the question is, with the 240 meters of fence, ultimately what we're going to look at is what's the maximum area that we can fence in. But on the way there, we are going to find an equation. So I've got this side is going to be called x, and if that side is x and it's a rectangle, then that side has to be x. And if I've got 240 meters of fence, and I put x on the left and x on the right, how much is left for the length here? Do you know? It's 240 minus the two x's, minus 2x. And then I've got this rectangle with a length and a width. So I can find this area in here, length times width. That's all it is. So down here, when I'm answering this question and I need to do length times width, but it says in terms of x. But I have it up there. What's my length? 240 minus 2x. That's my length. And what's my width? X. And that's it. You don't have to multiply that out. You don't have to say 240x minus 2x squared. That's it. That's the answer. That is the area as a function of x. And what is x? X is how wide we decide we're going to make our fence. All right, now let's look at B. It says what side length gives the maximum area. So that's what I was talking about before, that we're going to find the maximum area. Well, guess what? This is a quadratic. Do you see that? That if I were to expand this, it would be 2x squared. And what's more, it would be minus 2x squared. So do you want to think about that for a moment? That if I have a quadratic, that means a parabola. And if I expanded this, it would be negative 2x squared. Well, what does that say about the parabola? It's opening downward. And I've got x over here. And do you know what's on this axis? I mean, think about what we've been talking about in this problem. Hopefully you can say what the vertical axis is. It's area. So based upon different values of x, like what I'm going to decide my width is, that's going to produce a different area. I could do a short and a x and a very long length. I could do a wider x or a fatter x, like that. So I could have all these different choices of what is x going to be. And depending on what choice I use for x, that's going to change the area. So we want to know what's the maximum area, and we don't have to guess x's, and we don't have to calculate different values of area until we find it. We've got this expression here, this formula, this function. And what do I know about it? It's quadratic, and it's negative 2x squared. It opens down. What else do I know about it? Remember, in a discussion of quadratics that the x-intercept is when y equals 0. Now, hopefully we know that here in this problem, the y is right there. Do you see that? It's right there. That's the y. A of x is the y. So I want to let that be 0. I want to let a of x be 0. A of x equals 0. And then what would happen if a of x were 0? Well, just look. So this would all be 0. And then how do I solve that? Again, maybe you recall that to find the zeros, the x-intercept, what could you do? You can factor. And if you can't factor, you'd use the quadratic formula. But can we factor here? Of course we can. There it is. It's already factored. So what are the zeros of this? The zeros of this are x equals 0, from here. So I've got x equals 0 from there. And then I've got, from this one, I've got 240 minus 2x is equal to 0. And we could solve that for x pretty easily and get 120. Those are the x-intercepts. So over my graph over here, I've got 0 and say 120. It's a negative parabola, so it's opening down. And what's the maximum area? Up there. And what's up there? It's the vertex. All right. Well, where's that vertex? We've done a lot. You've probably done a lot in the past about finding vertexes and maybe using negative b over 2a. Maybe you've completed the square of an equation. Maybe it's given in the form of the equation. But we have it here. I think if you just think about it. Where's that vertex at? Well, if this is at 0 and this is at 120, where's the vertex? It's at 60, right? It's halfway in between. So what side length x gives the maximum area that the field can have? 60. That's going to do it. And then the last question, what is the maximum area that the field can have? I'm going to plug in 60. So right here, I'm going to plug in 60 for x, right there and right there. So a nice notation for that is that I'm doing a of 60, plugging in a 60 for x, 240 minus 2 times 60 times 60. So that's 240 minus 120, which is 120 times 60, and that's 7200. So 7,200, and what were our units? Meters. That's the maximum, meters squared. That's the maximum area. Okay, so that should be a pretty manageable problem for someone who understands quadratics. And we'll look at another application here, hopefully pretty quickly, where we've got 48 centimeters of wire, and I'm going to make 2 squares, and I want to find the minimum area. If this square is x by x, then its area is x squared. And then how much do I have left for this square? Well, I started out with 48, and I had to use, how much did I use over here? X, 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 x. So I used 4x. which I have to subtract from the original 48. And then how long is the side of this little square? It's going to be the amount of wire that I have divided by 4. Let's simplify this a little bit. Looks like 12 minus x. Okay? So that's a side of this is 12 minus x, 12 minus x. So what's the total area? You should be able to do that. A of x is equal to x squared plus 12 minus x squared. Simple enough. And then what are we being asked to do? We're being asked to minimize. So minimum area. And of course, the first question is what value of x will minimize the area? What did you get from the previous one? It's all about the vertex. We got to find the vertex. So for this one, I'm going to go, where is the vertex? Remember the other one, we were able to find it by using the zeros. Well, here we're gonna have to do the, let's get the quadratic. X squared plus 144 minus 24x plus x squared. All right. So then we can simplify that, right? So it's 2x squared minus 24x plus 144. 2x squared minus 24x plus 144. And what's the vertex of that? Well, the x-coordinate of the vertex is negative b over 2a. So that's, what is that? 24 over 4 is 6. Well, that's the value that's going to minimize the area. And then what is the area? I simply need to do a of 6. Plug 6 into the area equation. And that's going to get me 36 plus 12 minus 6 squared. Well, that's a 6 squared also, right? 12 minus 6 is 6. 6 squared is 36. So that's 36 plus 36 is 72 centimeters squared. And just notice on this one, it was a positive x squared. So if we had looked at this graphically, as we did on the previous one, we would have different x's are going to yield different areas. And it's positive, so it's opening upward. So this was going to be a parabola that went like this. So in this case, we were looking for the minimum, the bottom. And that's a couple of applications, a couple of word problems that use quadratics.